9.3, connecting graphs and rational equations. So here we have a rational equation, and there's two different ways that we can solve this. First, we're going to talk about algebraically, and then we're going to look at graphically. Okay, so first of all, let's look at this guy here. What are the non-permissibles? Well, I can see that x cannot equal 4. This guy here is just x minus 4, x plus 4. The difference of squares. Okay, because of this factor right here, I also know that x, or this factor right here, I also know that x cannot equal negative 4. So those are my non-permissibles. Okay, so I'm solving this algebraically. When I solve it algebraically, my strategy is I'm going to eliminate fractions. I cannot spell all of a sudden. Eliminate fractions by multiplying. Okay, and I'm going to multiply by the greatest common denominator. So my biggest common denominator is going to be x minus 4, x plus 4. So I'm going to multiply everything by x plus 4, x minus 4, x plus 4, x minus 4, x plus 4, x minus 4. And watch this. We're going to have some elimination. These are the same. They are just 1. So we're just left with 8. Plus 1 times that is going to be x minus 4, x plus 4. Okay. Here, my minus 4s, x minus 4s, eliminate. So I just get x plus 4. So I've gotten rid of all fractions. Okay. Now I need to collect like terms and solve. So here I have 8 plus, I know this is a difference of squares. We should be getting really quick at recognizing and being able to FOIL in one step. Doesn't mean it's a bad thing if you have to FOIL and actually do it out, but by grade 12 you should be snappier. Okay, if you need to do it though, that's fine. Let's get everything to this side. So I have x squared minus x. I have 8 minus 16, which is negative 8, and I'm subtracting another 4, so I get 12. Okay, now I need to factor this. I need to find two things that multiply to be negative 12, and they add to be negative 1. Those are going to be 4, and negative 4 and positive 3. Solving, I get x is equal to 4, and x is equal to negative 3. Now right away I should know I need to reject one of these. My non-permissible value said that x could not be plus or minus 4 right here. So I am going to reject this guy. And my answer is x equals negative 3. Okay, so we can also do this question graphically. So when I do it graphically, there's two ways I can do it. Okay, first of all, I can put everything over to one side and graph it. So if you'll remember, I had 8 over x squared minus 16 plus 1 equals 1 over x minus 4. I can bring one side to be 0, and I can get 8 x squared minus 16 plus 1 minus 1 over x minus 4 equals 0. I can graph, and I can use x-intercepts. Okay, so that's the first strategy that I can do. So I go to Desmos, I put it in, I get everything to be 0, and I look at my x-intercept. It looks like I have just one, and sure enough, that is at negative 3. Okay, that's one strategy. The other strategy I have is I can do the right-hand side and the left-hand side, put them as two separate graphs, and then look where they intersect. So that's what I did here. I did one side, the other side, and I look where they intersect, and they intersect at -3. Okay. Or my other strategy is graph both sides. And we're going to do the x coordinate of intersection. We did that, and we also got x to be -3. Okay. Let's try another one. Okay, here we have 6 over x plus 2 plus x minus 5 is 0. We need to solve two ways and always look at non-permissibles first. So right away I have a denominator here, so I need to look at the non-permissible. Here x cannot be -2. Okay, so let's try algebraically first. We have 6 over x plus 2 plus x minus 5 equals 0. So my strategy again is going to be to eliminate all fractions. I want them gone. So I'm going to multiply every single term by the greatest common denominator. Okay, so that is x plus 2. So I'm going to multiply everything by x plus 2. That's allowed. Okay, when I do that multiplication, I'm just going to be left with 6 plus x times x plus 2 minus 5 times x plus 2. Here, 0 times x plus 2 is just going to be 0. I'm going to expand and collect like terms. 6 plus x squared plus 2x minus 5x minus 10 is 0. I'm going to write in descending order. X squared, I've taken care of that one. I have 2x minus 5x, so it's minus 3x, taking care of those. I have 6 minus 10 would be minus 4. Okay, a couple strategies I can use here. I could factor, I could complete the square, I could graph. Well, it's said algebraically, so I probably shouldn't graph. Quadratic formula. I think I can factor this. I need two things that multiply to be -4 and add to be -3. What if we tried -4 and 1? I think that works. So I would get x equals 4 and x equals -1. Are either of those a non-permissible value? No. So they both seem to be correct. Now, the other way to solve this is we could graphically put this in. So this one already has 0 on one side, so I'm just going to graph this side of the equation. I am going to look at the x-intercepts, and hopefully we get the same answer. Okay, here I have graphed it, and it looks like I have -1 and 4, so the same answer. So it said to solve two ways. Okay. Next up. This one, it says solve graphically. In this case, we could bring everything to one side and use the x-intercepts, or we could graph the two sides and look. So I've already looked at here, and I'm taking the x-intercepts, so there are my two answers. And then non-permissibles. Well, here, x could not be. Let's see what x could not be. So 3 minus 2x cannot be 0. -2x cannot be -3. X cannot be 3/2. I divided them. Okay. Final question I'm going to do with you. So we have a basketball player. A player's free throw percentage is given by dividing the total number of successful free throws by the total number of attempts. So far, Eva has attempted 19 free throws and has been successful on 12 of them. If she is successful on every attempt from now on, how many more free throws does he, I guess Eva's a boy, need to attempt before her free throw percentage is 80%? Okay, so maybe Eva's not sure of their gender. Actually, I'm just going to make her a she. Okay, so she's done 19. She's gotten 12 of them. How many more does she have to do to get an 80%? Well, if she does X more and gets them, it's like adding X more to each one because she's successful on every one. So that's added both to the bottom and the top. So this is the equation that we are trying to solve. So I am going to multiply the top and the bottom by 19 plus x. Sorry, the left side and the right side. Okay. Expanding that, getting x by itself. I am going to get 12 plus x equals 15.2 when I did 19 times 0.8 plus 0.8x. Okay. I want x's on the left side and numbers on the right side. So I have x. I'm going to subtract 0.8 of an x. I'm going to get 0.2x. I have 15.2. I'm minusing 12. So I will get 3.2. Dividing both sides by 0.2. 3.2 divided by 0.2 is 16. So we can check that. Does that give us 80%? Does 12 plus 16 over 19 plus 16, does that give us 80%? So in other words, that gives us 28 out of 35. 28 out of 35. Bingo, 80%. So we did it correct. So she would have to do 16 more free throws.